In this week's problem, we're looking at a square that has a shaded region inside, and our job is to find the area of the shaded region. Well, the beauty of this problem, it can be solved several different ways. Way one is to notice that the four corners of the square show right triangles that have legs of 8 and 15. And then some of the problem solvers knew of this guy, Pythagoras, and his theorem, the Pythagorean theorem, and they applied it. And in this case, if they can figure out what C is, they can square it to get the area of the shaded region, because they also knew that the shaded region is in fact a square itself. So to apply the numbers we're given, the A is 8 and the B is 15, so 8 squared plus 15 squared equals the area of the shaded region. Another way to do the problem is to add the 8 and the 15 and get that each side of the big square is 23 units, so the area of the big square is 23 times 23, 23 squared, or 529 square units. And then if we can subtract the area of those four white right triangles, we can get the area of the shaded region. Well, each triangle is 1/2 the base times the height, and in this case, the base and the height are 8 and 15, so each triangle is 60 square units. And there's 4 of those triangles, and 4 times 60 is 240. So we subtract the area of the whole thing minus the 4 right triangles to get the area of the shaded region. The third way is to look at one of those right triangles and realize that we could put 2 of them together to make an 8 by 15 rectangle, which is 120 units. The other 2 right triangles could go together to make another rectangle. 2 120 square unit rectangles makes 240 square units. We subtract that from 529 to get the area of the shaded region. And to summarize, in our first method, it was 8 squared plus 15 squared is the shaded region. In our other 2 methods, we ended up with 529 minus 240 is the shaded region. We show the work, do the math, 289, the answer to this week's problem of the week.